Never seen
have them leave like their ears blasted.
There's a what?
Okay.
Is it what?
Okay. Now, on numbers 3 and 4, we're going to practice what we talked about last time. Okay, which is graphing exponentials. So we have here 4 to the power of x. What always works when graphing?
The chart.
The chart, the table. Okay, so let's go ahead and give ourselves a table. X on one side, y on the other. Okay, I like plugging in -2, -1, 0, 1, and 2. You could actually choose any numbers you wanted for x. Might go off the graph. That's why I like choosing these ones. Okay, so we're asking if we take 4 to the power of these numbers, what are we going to get? Let's start with the positives. That's always a little easier. What if I were to plug in 2? What is 4 squared?
8.
No, it's 16.
4 times 4?
Yeah, 16.
16. Good job. What about 1? 4 to the first power. Don't overthink it. 4. What is anything to the power of 0? 1. Okay, now the negative exponents, they just flip them. So -1, instead of 4 over 1, it is
4.
1 over 4.
And then 1 over 16.
1 over 16. Okay. Easy peasy. These become our coordinate points, x comma y. Okay, that's why we're putting parentheses around them, little coordinate points. So now we can go ahead and put these on our graph. So I have -2 for my x, and then it goes up 1/16. That's like barely up at all. -2 up 1/16. Oh, sorry. I won't be able to see that. Okay, then I'm at -1 up 1/4. Teeny bit higher than the last point. Still not high at all. Okay, then 0 up 1. 1 up to 4. 2 up to 16. Okay, and these are what our exponential graphs look like. I didn't connect those dots too well. Oh well. Okay, remember exponents get really big really fast. They shoot off. Okay, so let's do that again. On number 4, we now have 3 to the power of x. So instead of 4 to the x power, it's just 3 to the x power. Let's go ahead and give ourselves a graph, a chart. Did we already do this today?
Yep.
Did we already find the coordinate points for 3 to the x power?
Yeah, we did that one.
Yep. Let's not do it again, right? Let's just copy down what we got. -2, -1, 0, 1, 2. Okay, what did we get when we plugged in a -2?
1/9.
1/9. Beautiful. What did we get when we plugged in a -1? Look on the board.
1 over 3.
1 over 3, 1/3. What do we always get when we plug in 0? 1. What do we get when we plugged in 1?
3.
3. And what do we get when we plugged in 2? 3 squared.
9.
9. Okay. Awesome job. Okay, some of you guys have even started to graph those. Let's go ahead and do that. Let's put these coordinate points on our graph. Okay, so I have -2 up 1/9, -2 up 1/9, again, just barely up. -1 up 1/3, little teeny bit higher. 0 up 1. 1 up 3. 2 up to 9. And again, there's our exponential. Okay. Alrighty. Show me a fist of 5 on graphing exponentials, you guys. Finding those coordinate points and then putting them on a graph. How are you feeling? I could take a test on graphing that right now, get 100%. And a little more practice, anywhere in the middle. I have no idea what you're talking about. Nice, love it, love it. Okay, so here comes the fun stuff. We said that exponents and logarithms are inverses of each other, just like addition and multiplication. No, that is not correct. Addition and subtraction and multiplication and division are inverses of each other. Exponentials and logarithms are inverses of each other. Okay, so it wants us to convert an exponential to a logarithm. Okay, and here's what this is going to look like. Let's say I have 2 to the 3rd power, so 2 cubed. Let's figure out what is 2 cubed going to give me. What is 2 times 2 times 2?
6.
Very close. 2 times 2
4.
4.
times 2?
8.
8. So 2 cubed is,
2, 4, 6.
ooh, that is 2,
Oh, wait, never mind.
4, 6. That's counting by 2s. This is multiplying by 2 on that last one.
Yep.
Great, but great question. Okay, so 2 cubed equals 8, right? That's a true statement. Let's convert this to a logarithm. 2 is my base. Okay, so grab your base. We're going to write log, meaning logarithm, with the same base. Okay, we grabbed our base, and this is the kind of trick. We're going to move in a circle. So we're going to go from our base to our answer. So log 2 of 8. Then we're going to go back to our power. Equals 3.
Oh.
Log 2 of 8 equals 3. And you're like, what in the world is this even talking about? Okay, so logarithms, what this is saying, okay, I want you to write this sentence. What power of 2, meaning our base is 2, gives us 8? What power of 2 gives us 8? Well, what was the power of 2 that gave us 8?
3.
It was 3. Nice. So that's what logarithms are saying. What power of 2 would give us this 8? Well, we know it's 3. Okay, we think we can convert some logarithms back to exponentials? I think so. Okay, number 6. What I want us to do is actually write out the sentence. Yes, you're going to get so annoyed with writing sentences, but that's what we're going to do. Okay? So what power, we're just going to write the same exact sentence. What power of what? What's our base this time? What's right by our log? For number 6. What power of, what's my base?
2.
What's my base?
Oh, no, 17.
17 gives us 289. What power of 17 gives us 289? What power of 17 gives us 289? 2. So how we write this in exponential? 17 is our base. To the power of 2 equals 289. What power of 17 would give us 289? It would be 2.
Is that the answer?
That is the answer. We just rewrote it from a log to an exponential. That's all it wants us to do. Convert each equation in exponential form. Kind of easy?
Yeah, it's kind of easy.
Nice. Okay, let's do it again. I really think writing it in a sentence is helping us understand what's happening here. What power of what? What's our base? What's right next to my log?
3.
3 gives us What? What's right next to the 3?
2.
Ooh, what's
Oh,
right? 9. What power of, whoops, I totally forgot to write 3. What power of 3 gives us 9? Well, what power of 3 gave us 9?
2.
2. Okay, so let's go ahead and rewrite this in exponential form. 3 squared, or to the power of 2, gave us 9. Ooh, nice, nice. Okay, let's practice that some more. What, Braden? These are taking like 5 seconds. We can do all 4.
They do.
Okay. We can do it, I promise. We'll get done with this whole notes in like, seriously, another 5 minutes. Okay, let's write out the sentence because that's helping us understand. What power of, what's my base for numbers 8? 8 gives us, what's right next to the 8?
64.
Nice. And what was the power of 8 that gave us 64? Equals 2. Okay, so now we just rewrite it in exponential. 8's my base. To the power of 2 would give us 64. Is that true? 8 squared equals 64?
Yeah.
Yep, that's true. Ooh, I know. Maybe we'll do number 9, but then we'll switch 10 and 11 up, and I'll show you what I mean in a second. Okay, number 9. What power of, what's my base?
36.
36 gives us what? What's right next to the 36? 6. What power of 36 gives us 6? What was our answer?
36 to the power of 1/2 equals 6.
Oh, I love it. 36 is my base. To the power of 1/2 would give us 6. Okay, I'm gonna think of 2 different ones just right off the top of my head for number 10 and 11. Instead of converting from a log to an exponential, let's go backwards. Let's convert an exponential to a log. So let me think. So let me just make sure my math is correct here. Okay. Okay, so let's do this one. So now it's in exponential form, right? We don't see any logs. We want to take this to a log, meaning our answer will have the word log in it. Okay, so when we're converting back to a log, what is my base? Kaylee?
2.
2. Okay, remember the base always goes next to our log. Little trick, base, think basement. It's on bottom. Okay, remember how we went in a circle? 2 to the power of something would give us what?
35 equals 5.
Nice job. So 2 to the power of 32. Oh, not 2 to the power of 32. 2 to the power of something would give us 32. That something is 5. Ooh. So we used our little circle trick. Start with your base, go to your answer, end with your exponent. Okay, let's try that again. Let me get another one here. Ooh, good one. Okay, let's do... Let's try this one. See if we can convert this to a log. Okay, let's use our little circle trick. Start with our base, which is 9. So that goes next to our log. Log, base, and 9. Grab the answer. Oops, totally wrote that backwards. 729 equals 3. Ugh, I wrote that so bad I'm just gonna have to write it again. Log 9 of 729, meaning what power of 9 would give me 729? 3. Not too bad, not too bad. It's brand new. So show me a fist of 5 on converting logs. How you feeling? I can take it from a log to a power, and I can take it from exponential to a log. Nice. Okay, awesome. 3s and 4s, I like it.